So in this lecture, we are going to cover basic concepts of second order ODEs. First of all, we will define what is a second order ODE. Linear ODE of second order. Linear ODE of second order. An ODE of second order is called linear if it can be written as y double dash plus px y dash plus qxy is equal to rx. So if any ODE which can be written in this format is called ODE of second order, which is linear. So it is a linear ODE of second order. Call it equation 1. Now here Px, Qx and Rx are functions of x or constant. One thing to note is that if Rx is equal to 0, then this equation becomes y double dash plus pxy dash plus qxy is equal to rx. And if rx is equal to 0, then this equation is called linear homogeneous ODE of second order. If rx is not equal to 0, then this is linear ODE of second order and also non-homogeneous linear ODE of second order. So any ODE which can be written in this format is a linear ODE, and if the term Rx equals 0, then it is homogeneous linear ODE of second order, and if Rx is not equal to 0, then it is non-homogeneous linear ODE of second order. So now coming to the examples. First example is y double dash plus xy dash plus y is equal to x e to the power x, x e to the power x, y double dash plus x y dash plus y is equal to x e to the power x. So we can clearly see that this equation can be seen in this format also, y double dash plus pxy dash plus qxy is equal to rx. So when we compare this equation with this equation, we can clearly see the coefficient of y double dash is 1. The value of pxy, here px is x and the value of qx is 1, and the rx term is not 0, which implies that this is non-homogeneous. Also, it is linear. So when this equation can be written in this format, it is linear, and if Rx term becomes 0, it is homogeneous. But here Rx term is not 0, so it is non-homogeneous. It is non-homogeneous linear ODE of second order. Non-homogeneous linear ODE, linear ODE of second order. Next, coming to the second example, we have xy double dash plus y dash plus xy is equal to 0. We can write this as y double dash plus y dash by x plus y is equal to 0. Clearly we can see that it is of this format, but the Rx term here is 0. This implies that this is homogeneous linear ODE of second order. This is homogeneous linear second order. We can take one more example. So the third example is y double dash y plus y dash square is equal to 0. You can see this cannot be written in this format because the coefficient of y double dash is y itself, and if we multiply it by y, then also it cannot be written in this format. So it is non-linear, and also Rx term is 0 here. So it is homogeneous non-linear ODE of second order. It is homogeneous non-linear ODE of second order. So with these examples, you can clearly understand what exactly a nonlinear or linear second order ODE is, whether it is homogeneous or it is non-homogeneous.